Hi everyone, so in this video we're doing our last lesson for chapter 1 and it's on inverse functions. Okay, so first let's talk about what is an inverse function. So inverse functions undo each other, right? So it's another way to think of it is that the x's and y's switch. So if we have originally xy, the inverse is going to be yx. And we denote the inverse function with f-1 of x. So one thing about them is that if two functions f and g are inverses, then when you compose them, like what we learned in 1.6, it always comes out x. It doesn't matter which one you plug into the other, it should always equal x. Okay, so it's called the composition rule. And if we had to verify if two functions are inverses, that's how we would do it, is plug one in and see how it comes out. Okay, so over to the right, it says how we would find an inverse. We switch the x and y and then solve for x, and that's it. And then we use f(-1) of x to show that it's the inverse function. And then we have to look at the range of the original to make sure it actually is a function. So let's take a look down there at domain and inverses and how that works. So if this is our original function, the domain is all real numbers. It's a parabola. So that would be from -infinity to infinity. And then the range is -infinity and stops right there at 1. Okay, good. So now let's graph the inverse of this. So we're going to pick some points on this and switch them to get the points for the inverse. So we have this point right here. The vertex is 2, 1. So the reflection of that would be 1, 2. So there we go. We have a point here at 1, 0. So we would have 0, 1. Another point here at 3, 0. So we'd have 0, 3. We have 0, -3. So that would be -3, 0. And then 4, -3. So the reflection inverse would be -3, 4. Okay, so now here is our inverse. So I just found those points by switching the points in the original. Okay, and we're going to talk about over here is that it's reflected over the line y equals x. So what's the domain of this function? So as we're moving left to right, where do we touch our graph? So since we have arrows pointing this way, we're at -infinity, and then it stops right there at 1. So our domain is going to be from -infinity to 1. And our range, our graph, is going to go up and down as it goes out. So it's going to be from -infinity to infinity. So as you can see, what happened here is that our domain and range switched. So our domain from the original function is now our range, and our range is now our domain. I can find a highlighter in another color. Here we go. Well, that didn't work out very well. You can't even see it. Well, maybe. Okay, so anyways, you switch your domain and range. Okay, and that's what this is talking about. So that brings up some good things about if it's still a function or not after you switch it, which in this case, we're not a function anymore. Okay, vertical line test, it hits more than 1. So sometimes if we wanted to make this a function, we'd have to restrict it, either that part of it or that part. Okay, but we'll talk about that later. So now let's look at the graph part. So they are symmetrical to y equals x, which was what I just talked about. Vertical line test will tell if it's a function. The horizontal line test is if you look at the original function and it doesn't pass the horizontal line test, so if you hit it more than once, then it's not going to be a function. Okay, so here is just an example of a picture of the function. So you see the lighter colored one was the original, and then the darker colored one is the reflection over that line y equals x. So another example of them switching. So if the points are on the line, those stay, but then the other points move to the opposite side of the line. Okay, so for this graph, if we draw a horizontal line, we end up touching it more than one place. So the original is a function. The parabola is a function because it passes the vertical line test, but the inverse is not going to be a function. So that's what that tells us. So the inverse It's not a function. Okay, so let's do some examples. Okay, so it says to find the inverse and the domain and range. So I'm going to have us find the domain and range for both the original and the inverse. Okay, just to see if they always work out like it did on the front, where they switch. So the domain of this one, remember to find the domain of a rational, we look at the denominator and set it equal to 0. So if we set this equal to 0, we get that x is equal to 2. So that's where our restrictions are. So we can't have 2. So this is going to go from negative infinity to 2, and then from 2 to infinity. Okay, so I'm guessing we don't remember the rule about the vertical asymptote, or this is for vertical asymptotes. We have a vertical asymptote at 2. The horizontal asymptotes in a rational function, which we will get to this, I think, in chapter 2, I don't remember. But it has to do with the coefficients. Okay, so if the exponents are the same, then you just take the coefficients. So it has a horizontal asymptote at y equals 1. So that means our graph doesn't exist there. So that means our domain would be everything but 1. So negative infinity to 1, and then 1 to infinity. If you have, if you're able to, if you're using a computer, go on to Desmos and graph this, and then you'll see why this exists, because it's one of those that has the 2 parts. But you can see where the asymptote will be, right? And like I said, we're going to get more to this, the horizontal asymptote in chapter 2, but I didn't want us to write the wrong range, okay? Okay, so let's find our inverse. So we change this to y, and then switch our x's and y's. So we'll have x equals y plus 3 over y minus 2. So now we just have to solve for y. So the first thing I would do is multiply, cross multiply here to get rid of the fraction. So we'll have xy minus 2x equals y plus 3. So now we have 2 different pieces with y's, so I want them on the same side. So I'm going to add 2x and then minus y. So xy minus y equals 2x plus 3. Be careful because those aren't like terms. That's an x in front of it. Okay, so now again we still need to get the y by itself. So since both of these pieces have a y, we're going to factor it out. So we'd have y times x minus 1 equals 2x plus 3. And now to get y by itself, we just divide by this parenthesis. So we'd have y equals, or y inverse, equals 2x plus 3 divided by x minus 1. And that is our inverse. So now let's look at the domain and range of it. So the domain, if we set the bottom equal to 0, we get 1. So it's going to be negative infinity to 1, 1 to infinity. The range is the coefficients in the front, so that'd be 2 over 1 or 2. So we'd go from negative infinity to 2, and then from 2 to infinity. So again, graph that one so you can see how it changes. But if you look, our stuff changed just like we talked about in the front. You have to be careful though, because sometimes weird things happen and it doesn't always work like that. Okay, so I'm going to let you find the domain and range for both at the end. So right now I'm going to just work on switching it with you. Okay, so switch the y and x. So x equals the square root of 2y minus 5. So how do we get rid of the squared? Or I'm sorry, the square root. we square both sides. So we have x squared equals 2y minus 5. And I think we should be good from there. So add the 5. And then divide by 2. So y inverse equals 1/2 x squared plus 5/2. And then we'll find the domain and range of the inverse 2. Okay, so we'll come back and do the domain and range after we solve the other one. Okay, so for this one, we'll switch the x and y. And then to get y by itself, add 5. And then to get rid of the squared, we take the square root of both sides. So y inverse equals, remember when you're solving in an equation, to get the inverse you have to put plus and minus, because positive and negative work. Okay, so what I want you to do is find the domain and range of, for question 3 and 2, the inverse and the original function, so both parts, okay? Pause your video, find our domain and range. Okay, so for number 2, our original domain and range was 5/2 to infinity and then 0 to infinity. Remember, you take the inside and solve for 0 or for x. And then since the original function looks like that, that's why the range is from 0 to infinity. This doesn't move up or down, it has no parent translation. And then with the new one, it's a parabola, so negative infinity to infinity, and then the range is 5/2 to 2. So that's what I was talking about. Sometimes they don't exactly match. If this had a plus or minus, it would be negative infinity to infinity, but it doesn't, so that's why it starts at 0. So that's why it doesn't always necessarily match. Okay, so if we take a look at number 3, same idea here. This was a parabola, so we had those. It's shifted down 5, so that's why our range is from negative 5 to infinity. And then with this one, the plus or minus makes it not a function. Okay? So, because that makes it go like up and down, which is going to make it not be a function. So to make it a function, we have to take off the negative part. Okay? So that's why I made the range only go from 0 to infinity to keep it a function. Okay, so let's take a look at that last question. So here it says, which function, g or h, is the inverse of f? So we're trying to find the inverse of f, and we could just find it, but I want us to use the rule to determine if it is or not. So remember, the rule said that if the composition equals x, it's a function, okay? So let's plug in g into f and see what it gets out, and then plug h into f and see what we get out from there. So first we're going to do f of g of x. So that would equal 5 over, and now in my x I'm going to plug in g. Okay, so x minus 2 over 5 minus 2. So now we need to simplify that, and there's several different ways to do it. What I like to do is just to cancel out the denominator, because we have a fraction and a fraction. So I'm going to times by 5 over 5. So the top will get times by 5, and then the bottom will get times by 5. Okay, that means in the top, I'll have 25. And the bottom, I'm going to distribute to each piece. So when I times here, they cancel. So I have x minus 2. And then when I times here, I get 10. So that gives us 25 over x minus 12. So if this equaled x, we would have that those are inverses. So f and g are not inverses of each other. So let's try the other one. So f of h of x. So that is going to give us 5 over x plus 2 minus 2. So this is what we plugged in here to this x. Okay, so if we plus 2 minus 2, that's just 0. So we have 5 over x So then we can flip and multiply. Those will cancel out, and we just have x. So that means that h is the inverse of f. So f and h are inverse functions. So if we wanted to, we could have plugged in f into h and then worked out to the same thing. Okay, I just like to put them in f, but it doesn't matter. Okay, and that's it for 1.7. Werner out.